Welcome to How To. In today's How To video, I'll show you how to create a timescript file and upload it on our devices. All Phenon Accurate, Phenon XD, as well as RTI Pico of latest generation equipped with our Phenon mainboard can receive a net timecode. A net timecode signal can be generated using our LA player, LA recorder, or of course our LaserGraph DSP. If you have an external SMPT timecode, you can also use one of our adapter interfaces, which will generate a net timecode. This net timecode signal is a broadcast signal over network. So every single laser projector from LaserAnimation being connected to the network will receive this net timecode. Our net timecode being a broadcasted signal, you have to tell each laser what to do when receiving the timecode. To do so, every single laser is going to have a so-called timescript file. A timescript file is a very easy, small file which can be created on your computer, on editor, or of course, if you're using LA recorder, during recording process, at the end you can also select to upload your recorded frame as well as the net timecode directly onto your host laser. To do so, the timescript file has always the same, format. So you will always see, as you see on my screen, you will always start with the timing of your net timecode or timecode signal, and then we have different types of coding. So here it's quite straightforward. At time 0, we're going to tell laser, in our case my Phenon Accurate, to go to the media and to open the file which is in the test picture folder, and the file is named default. Then it's going to loop it, 0 meaning endlessly. So it's going to loop or play whenever receiving the timecode 000, going to play this default file endlessly. At 2 seconds, we see that it's still playing the same file endlessly, but we are giving a further instruction to our Phenon Accurate, meaning size 0.5. So at timecode 2 seconds, that default animation will suddenly be reduced by 50%. So it's not going to output at 100% size, but just at 50%. A second later, you see you have again the horizontal and vertical axis. So here it is going to be resized on the horizontal and it's going to be stretched on the vertical. A second later, using the code bright for brightness, we're reducing it from 1 being 100% here to 0.2, meaning to 20% of maximum power. A second later, at 5 seconds, we are sending, for example, the instruction stop, meaning there won't be any laser emission anymore. A second later, the brightness goes up to 100% and we're gonna start playing our DGC file, which is located in the same folder under test picture. And here we have a loop of 100, so that means it's going to be just looped for a certain period of time. And so on and so on. So you see, by simply changing or modifying your timescript file, you will tell your laser which file to use at which time. And of course, you can also use several different files which are stored on the SD card over a certain lapse of time. All those commands can also be found in our LA.toolbox user manual or also with Accurate or other devices. Once you made your timescript file, just make sure to save it under time and the extension being point or .tsc. So that's very important for the either Phenon Accurate, Phenon XD or RTI Pico to understand, to know, okay, it's a timescript file. You can first save it on your computer for later modifications. Once you're done, simply start your laser. Just gonna take a couple seconds to boot. And then you can either use the file manager at top, so the utility file manager located on LA.toolbox, or you can go on your device itself. So we have it here. You go to utility file manager and then you can simply select in which folder it should go. So here we see, for example, we already have in our folder demo show a recorded file, recording 01.if, and we have a timescript file as well. In our case, we said that it was going on folder test picture, so we open the folder test picture, and then we will simply take our timescript file, drop it on the test picture folder, and suddenly we see it's already loaded on the SD card. Once uploaded on the SD card of your laser, you can simply close the file manager window, and of course you have to tell your laser that it's gonna have to wait for a net timecode signal or a timecode timescript. So instead of having input either ILDA or AVB, you're gonna go on media, and very important, if you just select an IF file, it will just display it all the time. So you have to select the right timescript file. So in our case, we said our timescript or our test would be in the folder test picture, and it's here. Just select it, and now your laser is ready to display. So as long as it is on run, and it's gonna just wait for your net timecode. You have different options as mentioned. So either you have a DSP laser graph which can generate a net timecode signal, or you can also use an external adapter entering SMPT and outputting a net timecode. Another small hack is you could use, as you see here, our LA player by ticking the box here, send net timecode, and so as soon as I'm gonna press play, LA player will also generate that net timecode, which will go over network to every connected device. And it will simply play what we just programmed before. You will first see our default test picture at full size, then reduced to 50%, then one axis is going to be increased, color being changed, stop, a different test frame, and finally a circle with dots. All this just being generated or controlled by our net timecode. So as soon as I'm going to start, it will display. If I stop my timecode, of course, the animation immediately stops. If I resume it, it will just keep working from where it was before. If you see that one part of your show is either a bit too long or something else, or too large, you can, using our instructions that you have on the media, on the timescript file, you can amend, you can modify the content, the output of your device. We have in our user manual, as mentioned before, different instructions. So you see them here again on the screen. So with the coding file being the path and the file name. So that's basically where your content is. And so if you select that, it will activate this file and display its content. You have also the option timescript with the path file name. This is being used, can also be very interesting, that you can have one timescript which at a time will activate a different timescript file. So this is also something which can be very useful. As you see with instruction size, it goes from -2 to +2, so that's the global size or magnification reduction, default being at 1. We have again the horizontal and vertical from -1 to +1, so that's the size of X for the first and the size of Y for the second. You can also play with the position of your animation, of the output, going from -1 to +1 for both X and Y. The bright instruction or coding will play on the global brightness or intensity of all colors, so that's sort of master or intensity fader, while the coding color will allow you to play with the single color, so red, green and blue. So it means you could have your animation displaying, and with the timecode or net timecode signal being received, you can say that, for example, from second 5 to second 10, you're just going to play it in red, and then in green and blue and so on. So you can also amend, you can modify the true output colors just using a net timecode or a timecode signal. Loop is for the looping of your media, being loop 0, it's for endless. And finally, stop. So this stops the output immediately of every laser projector. So if all laser projectors, for example, at 1 minute have the stop instruction, as soon as your time code gonna arrive at 1 minute, your laser emission will be stopped on all laser. That's it for today's how-to. If you want to learn more about LA.toolbox or laser projectors, make sure to follow us here on YouTube. Stay tuned for more.